Hello everyone and welcome back to this next lecture. So in the previous lecture we had run the code on the microcontroller, but we found that it was not working as expected. Only one LED was flashing, the other LED was not flashing. Specifically, the LED connected to timer 1 was flashing because that is a red LED connected to the pin A10, whereas the blue LED connected to pin B9 was not working. So this is timer 6. So now I'm going to show you in this lecture how you can debug your code, especially when it is running. Now it's important that you are still in the debug mode and your code is still running, otherwise this will not work, right? Now until now we were always having a one-way communication. That is, we were compiling our code and downloading it onto the microcontroller. Now I will show you how you can reverse it. That is, you can now read the status of your microcontroller on your environment, that is CubeIDE, that is STM32 CubeIDE. So if you look here, you will see this is the editor, this is where your code is. This is the debug window which is just showing which is running. And you will see here there is another window which shows a number of different tabs. The first one is variables, then comes breakpoints. This is if you place any breakpoints in your code. We don't have any breakpoints. The next one is expressions. The next one is registers. Then comes live, and then comes something called SFR. Now these are special function registers, right? Special function registers, these are all the registers in your processor. And this is a great way to know the state of your processor as your code is running. So for example, in this case we have two timers. We have timer 1 and timer 6. So let's come over to timer 1. And let's look at the counter variable. This counter is the 16-bit counter. Now, timer 1 we know is running. So if you take a look, you will see that the timer 1 value is continuously changing. And the reason for that is because the timer is running. And since the timer is running, we are getting the red LED flashing on our experiment. But now let's go and have a look at timer 6. Let me just collapse this. And let's go and look at timer 6. And you will see here that if I just toggle live update, you see there is no movement at all. It is not changing. It is at 0. So really speaking, this timer is not working at all. So let's go and check out these, and you will see here too that there is no value at all. We have enabled it. Remember, we had enabled it and we had also set the ARPE bit. That is, we were saying that the ARR register, the auto reload register, which is the period register essentially, is going to be buffered. And all those are not there. Let's go look at the DIER, and the DIER is also 0. Now this is a clear indication that all our configurations have not been written. And I already said this to you that usually the culprit, when you do not enable the timer in the RCC registers, then in that case, any write you do, any configuration that you do to any of your timer modules will not work, because the module itself is not working. Any module, for any module to work, for any module to receive any changes, it must have a clock. It is like a human being. Without a heartbeat, a human being cannot live. In the same way, without a clock signal, no module, no electronic circuit can work. That is absolutely fundamental. So which means if all these values are 0, then it is very clear that our write has failed. So let me just exit this because we know what the problem is, and we need to figure out what error we have made in this configuration. That is, we are enabling timer 6 in this register APB1 ENR1. So we need to figure out what's wrong here. So I have written the number 0x40. Let's go and check out what this actual variable is. So this is the clock variable. This is the variable for timer 1. We know this is correct, so there's nothing to do. Let's go up here. And let's go to the register with timer 6. And this is the variable. So you see this is timer 6, which is bit number 4. And you can clearly see the mistake right away. In my confusion, or probably I was too busy creating this video and therefore I didn't know what I was doing, I wrote the number 4 because it was at bit 4. This is totally wrong. This is one hexadecimal number because these are 4 bits, and these are going to be 0 because we are not changing them. But here, this is the bit number 4. This is the next hexadecimal number, which means if I want to set this bit, I need to write a 1 in this hexadecimal number and not a 4. If I write a 4, that means I'm setting this bit number 6, but that's useless. That's reserved anyway. So therefore, this is the mistake I made. Let's go over here and make that change. This is merely 1, 0. Now I'm going to go and do another compile. Clean and compile. And let me go into the debug mode. So I'll just go to run and debug. And before I bring the microcontroller into the video, I would like to go and do the same investigation, that is, look at the registers. So our code is downloaded successfully. Let me run it and let me go to the special function register. So this is timer 6. You have to right click and click live update. And now you see the timer is changing. So this means that this was the mistake. I had actually not enabled the timer correctly in the RCC register. And this just shows how critical that particular statement is. Without that statement, the module completely does not work. So now that this is working, I can go and bring the microcontroller into the video. So you will now see the microcontroller in the video, and now you will see both LEDs are flashing. And it is very clear that the red LED is flashing much faster than the blue LED. And if you take a look, typically this is indeed seems like a 1 second time interval, and this seems like a 2 second time interval. So therefore, at least now our timers are working correctly. We have set up our project correctly, and now the best part is we have now learned how to establish interrupt service routines and timer intervals. And this is something we will also use in the next section and the section after that, because almost everything we do in power electronics is in discrete time, and therefore this time interval becomes fundamental in almost any control we implement in power electronics. So with this, I'm going to end the microcontroller video. And we have also arrived at the end of this lecture, and for that matter, the end of this section. So I hope this much was clear to you, and I hope you also understood how to use this debug panel, that this debug panel is very convenient to understand how these things change. And for instance, the only thing you must remember is when you do expand, you must click on toggle live update. Only then will you know the value is changing. And you can see here the value is actually changing very rapidly, and this is clearly an indication that the counter is running correctly. So if any of this did not work, you faced any other errors, or you made some other mistake very different from mine, please post in the Q&A forum and I'll be happy to help you. Otherwise, I will see you in the next lecture where we will conclude this section. Thank you so much for listening, and goodbye for now.